Let us take one more example of the binomial theorem, and the sum looks like root 3 plus root 2 the whole raised to 4. So in this case we have a as root 3, we have b as root 2, and we have n as 4. Let's first find the values of 4c0, 4c1, 4c2, 4c3, and 4c4. And we know that 4c0 and 4c4 are equal, 4c1 and 4c3 are equal, and 4c2 will be calculated also. Now 4c0 and 4c4 is 1, 4c1 and 4c3 is 4, and 4c2, let's calculate that. So 4c2 is equal to 4 into 3 upon 2 into 1. So 2 1s are 2 2s are 4, 2 3s are 6, 6 upon 1 is 6. So we have 4c2 as 6. Let us rewrite the question. Root 3 plus root 2 the whole raised to 4 is equal to 4c0. We can write 4c0 also as in brackets 4 and 0. Will then write a raised to n, so where n is 4, plus 4c1 a, last time it was 4, so this time it would be 1 less, it would be 3, and this time we'll introduce the b, so root 3 raised to 1. Remember, 3 plus 1 is again 4. That was the original value of n. Plus 4c2. Now when we have this as 2, the value of root 2 will be raised to 2. And we'll have this first part a, root 3 squared this time, 1 less than the previous time. And root 2 also will be squared. Again, 2 plus 2 is 4. Plus 4c3. We'll have the a, that is root 3 raised to 1, and the b, the root 2 raised to 3, means cubed. And finally we have 4c4. We won't have the first term a, we'll directly have the second term root 2 raised to 4. So you can see that the index of a, that is root 3 in this case, decreases 4, 3, 2, 1, and then we don't have it. And b increases. In the first term we didn't have root 2, that is b, then we had b raised to 1, root 2 raised to 2, root 2 raised to 3, and then root 2 raised to 4. Now 4c0 we know is 1, we can ignore the 1. Root 3 raised to 4. Now root 3 into root 3 into root 3 into root 3. Root 3 raised to 4. Root 3 into root 3 is 3. Root 3 into root 3 is again 3. 3 into 3 is 9. So we can directly write 9 plus 4c1, and we know that is 4, multiplied by root 3 cubed. So we have root 3 into root 3 is 3 into another root 3. So we have 3 into root 3. So we'll have 3 root 3. Root 2 raised to 1 is simply root 2 plus 4c2, and 4c2 we know is 6, into root 3 square. Root 3 into root 3 is 3, into root 2 square. So root 2 into root 2 is also 2, plus 4c3. 4c3 is again 4, so the coefficients will repeat. Root 3 raised to 1 is root 3, and root 2 cubed. So we have root 2 into root 2 into root 2. So root 2 into root 2 is 2. 2 into root 2 is 2 root 2. Plus 4c4. 4c4 is 1. We can ignore that. Root 2 raised to 4. So root 2 into root 2 is 2. 2 into 2 is 4. Now let us simplify this further. 9 plus 4 3s is 12. Root 2 into root 3 is root 6. So we can write 12 root 6. Then we have 6 3s are 18. 18 2s are 36. So we don't have any roots over here. And then we'll take the last part. Oh, sorry, only this much. 4 2s is 8. Root 3 into root 2 is again root 6. And the last part is 4. Now we'll take the like terms together. 9 and 4 both are like terms. So 9 plus 4 is 13. Plus, oops, we also need to add 36. Okay, we can do it in the next step. Plus 12 root 6 plus 8 root 6. So remember, only 12 and 8 will add together. Root 6 and root 6 won't add. So it ends up to be 20 root 6. And finally, let's add 13 and 36 also. And we have 49. So 49 plus 20 root 6. So this is the answer, the expansion of root 3 plus root 2 the whole raised to 4. Now, just a bit or two. When we had the index as 4, when the value of n was 4, you saw that we had a total of 5 terms. This was our first term, then this was the second term, this was the third term, this was the fourth, and this was the fifth. So another conclusion that we can draw is when n is 4, the number of terms that we get is 5. However, we simplified the 5 terms and we got the final answer as again a binomial, a sort of binomial. So 49 plus 20 root 6, but originally the number of terms were 5. So if the index of the binomial expansion is n, we'll end up with having n plus 1 number of terms. Hope you understand this, and we'll catch you in the next video.